Support for Lab Out Loud is provided by NSTA, the National Science Teachers Association. NSTA works to ensure that all children have a quality science education. They provide resources like this summer's 6th Annual STEM Forum and Expo, which will be on July 12th through the 14th in Florida, and through publications like Blick on Flicks, which provides movie reviews with a scientific eye. Blick's most recent review takes a look at Dream Big, which is the movie that we'll be talking about in today's episode. Find out more about the National Science Teachers Association at nsta.org. You're listening to the Lab Out Loud podcast, Science for the Classroom and Beyond. Today we're looking at how education can help our students dream big and engineer our world.
If you want to survive in this 21st century, you need to show that you know how to learn what the problem is and try to find solutions for that. If you can do that, I don't care what subject you're in, you'll be successful. So it's creating people that can think and analyze and solve. That's what the focus of education should be. Content should be second.
That's up next on Lab Out Loud, but first I'm your co-host Dale Basler.
And I'm Brian Bartell.
Was that your dog?
Yeah. That was my dog.
It sounded like a
It reminded me of, like the little kids who crashed in on the podcast.
Oh, that reminds me. I should give the listeners a heads up. There is a 3D printer working away in the background during this episode's interview. Is that a 3D printer here in the background?
Yes. Do we need to stop that?
No.
It's
just it's perfect. It adds to the ambience. Brian and I are both novice 3D printers. If we were really good, we could say, I believe that's a MakerBot Mini.
That's a replicator too.
Replicator too. Oh, that's big.
You're in the right family, though.
Yeah. Okay, so you just heard Fredi. He's the one running the 3D printer in the background. Fredi's actually a nickname.
And that was given to me by my kindergarten teacher, so it's stuck since kindergarten.
No way. Really?
Yeah. Talk about a nickname that lasts forever.
Wow.
Fredi's full name is actually
Fredi Lavjardi. And Fredi is Farid for short, or Americanized version, Fredi. So that's how Fredi came from.
Fredi's here to talk to us today because he's featured in a new film that Brian and I got a chance to see. It's called Dream Big, Engineering Our World.
Yeah, it's an upcoming IMAX documentary, and it addresses, basically, for lack of a better term, the STEM initiative that we see happening across the nation.
What I really liked about the movie is it took these engineering stories, but really approached them in an emotional, very human perspective. And I watched it with my ninth grade son, who was really inspired by it, I think, after it.
And I think there are times when we're looking at new science standards and their engineering principles now in NGSS, and sometimes it's hard to think about where those actually fit into science teaching. And the movie helped me kind of ground that a little bit more, and I know it will for a lot of other people out there.
Yes, and especially after you hear some of the things that Fredi has to talk about in today's episode. Let's go to Fredi right now. He's going to talk to us about what his role is, basically what his day job is.
So I am the program director for the Center for Marine Science. It's a magnet program. It was originally created for desegregation, but that's no longer the case. It's a magnet program for marine science. So here at the school, we teach 4 different marine science classes, ranging from oceanography all the way to mammal biology. And so that's what I'm the director of. And then after school, I run a robotics program where we've done terrestrial or land-based robots and underwater robots.
And where are you?
Oh, I am in Phoenix, Arizona, at Carl Hayden High School, which is located almost in the middle of downtown, 35th Avenue and Roosevelt, the heart of the city.
Mm-hmm.
Phoenix?
And we're in the desert. So
that doesn't sound marine to me.
Yeah.
But I guess it was marine. Right?
Well, at some point in history, yes, it was marine. But the argument when people say, why are you teaching marine science? And it's because the oceans cover most of the world and control all of the climate that we have, even in the desert. So even if you're in the desert, you need to understand how and where your climate is coming from.
Well, we actually had something to do with that not too long ago. One of our Wisconsin schools participated in the National Ocean Science Bowl, and they won it a few years back from Marshfield, Wisconsin. And again, that was one of the questions. Why ocean science is in the middle of Wisconsin? And again, it relates to all of us and how we learn about our environment and the global perspective on the world.
Yep, that's exactly right.
Mm-hmm. Do you participate in the National Ocean Science Bowl as well?
No, we have our plate full with the robotics competitions we do. So it would probably be a fun thing for us to try, but we just don't have room for on our plate for that.
It sounds better when you can say you compete with robots. So there's that.
Yeah.
We have been familiar with the terrestrial robots. First Robotics is something we talked about on the show before, but tell us a little bit more about the idea of an underwater robot competition.
So an underwater robot competition is quite different from like a First Robotics where you're going head-to-head robot to robot.
Oh.
Almost every competition that I've seen dealing with underwater robots is a mission scenario. So you have a series of tasks that you have to accomplish underwater, whether it's measuring something, manipulating something, taking a sample of something. So there's all these different tasks that you have to accomplish. Sometimes it's a World War II submarine recovery scenario. Sometimes it's an Oceanographic Research Institute kind of study. It just varies on whatever the competition is emphasizing. And then the next level, that's a teleoperated, where the pilots actually drive or fly the robots, the ROVs, through water. Then there's the terrestrial competitions where, there's the autonomous competitions where you put the underwater robot in and you basically turn on a switch and it has to do everything autonomously. See, hear, navigate, pick up things, manipulate, whatever. That's the higher level of the underwater robotics competition. So there's the two levels, the teleoperated where they're controlling everything and the autonomous where the robot has to do everything on its own.
Now, do we have autonomous robots, I'm thinking in research and things like that, for underwater?
Oh, yes, they've been using autonomous robots for quite a few years now in research. The Navy's been using them too for naval stuff like spying and surveilling things like that.
Sure.
So they do. They have AUVs that can be out for months at a time, and then they come home and then they download all the data they collected.
What's their power source then?
In that case, what they use is a ballast system and solar charging, so they can go up and down and using the water to make them go down, and then they dump the water, and then they come back up, and then they charge. They can charge their batteries that way. They usually have fins on them, and those particular ones, and they're called underwater gliders, but they're still AUVs. They're autonomously controlled. They can even get their GPS coordinates when they come to the surface, but if they lose track underwater, they have to come back to the surface to figure out where they are.
Yeah, I think I've seen some magazine articles about them testing like salinity and tracking that all throughout the ocean. And
yeah.
So when did you get started in that competition, or when did you start looking into doing that?
So there was this was back in 2004. Actually, 2003. I'm sorry. My teacher friend and I,
That's all right.
Alan Cameron, we went to a workshop, and they were teaching us about underwater robots. And the idea is that there's not enough people going into the ROV technology and the marine technology field, so they wanted to kind of inspire teachers to get kids involved in these underwater robotics competitions. So to inspire us, they got a group of teachers together during the summer, gave us a couple $100, dumped us off at Home Depot, and told us we had to work in groups of 4 and come up with a robot to compete against the other teachers. So at the end of the week, they asked us, did you guys have fun? And we, of course, said yes. And they said, well, you can have this same kind of fun with your students if you bring them to this underwater competition that we hold. So that was in 2004 of June of 2004. And we took our first group of students there with the idea that we were going to experiment. We wanted to learn about this competition. We weren't trying to go for the win. And we learned from years of doing the robotics that we learn the most when we fail. And so when confronted against the two options, or with the two options of either entering in the high school category or university category, we decided, which one are we going to fail at the most? So we decided we'd get our butts beat by, the universities. So we decided we'd do that with the idea that we'd be taking notes and take all kinds of information down on the team's strategies, their components, and that type of stuff. And then in the evenings or at the end of the week or whatever, at some point in the competition, we'd put all these ideas up on the wall and say, okay, a year from now, if we could attack any of these things, which one of these things could we solve so that next year we come back stronger? So that was our strategy, was to go into this competition, not to try to fail on purpose, but that was our goal, was to learn as much as possible.
A fact-finding effort.
Yeah. And if by chance you happen to beat one university, that would be icing on the cake.
Now, we got a chance to see part of this story because it has been included, very exciting, into Dream Big, Engineering Our World, which is a new IMAX film. So we got to see sort of a camera view of what happened. So we know the rest of the story. Now, were the cameras there during that very event?
No, that was a reenactment.
Okay, I was like, how did they know?
You're like the second person who's brought that up. So,
so you send this team. How big is the team? How many students are on the team?
well, we originally had 6 students, and one of them was a female, and another one was a guy that was in summer school. And the deal was if he was making an A in summer school, he could go with us. Well, he couldn't keep that end of the bargain. And the girl, as soon as the summer hit, she disappeared. Uh-huh. So we were down to 4 students, and so that's the 4 that we ended up taking to the competition.
Well, okay, I actually want to go back to the beginning here when you were dumped into this workshop, because that, first of all, that's a professional development model in a sense that we don't often see. Let's put the teachers in exactly the same environment that we expect the students to be able to succeed in. Because did that work for you?
Oh, yeah.
Obviously it did.
It was, I don't want to brag or anything, but our group were the only landlocked teachers. We decided to stick together, and all the other teachers were from, coastal areas. And so we were really proud that out of the 7 events, we won 5 of the competitions.
Oh, wow.
So we were thrilled and excited. And of course, that just made our motivation factor go up a little more.
But Did you have any fun names like Coastless Group or something?
That's exactly what I was thinking.
And maybe like the desert something or other. But
yeah.
So no, it was pretty exciting. And what we saw as an opportunity was this was another area or realm of robotics that we could expose our students to, and knowing that the field of oceanography is only going to get bigger, especially since more of our planet is covered with water than anything else, and that we're going to have to turn to the ocean for a lot more resources than we currently do. And the fact that robots are really quickly moving into autonomy, it just seemed like a natural progression for us to get our students not only exposed to the land robots and air robots, but water robots as well.
Now, you are still doing those competitions on a yearly basis then, correct?
Yeah, we do a different underwater competition now. The one we did in 2004 was called MATE National ROV Championships, and that was Marine Advanced Technology Education Center's National ROV Championships. The current one that we do, and it was a hiatus between that competition and the one we currently do, which is called the Association for Unmanned Vehicle Systems International RoboSub Competition. So now we are competing against 40 universities from 12 countries, and there's only 3 high schools competing in that type of competition. It's 30 minutes of autonomous operations underwater in a pool at the naval base in San Diego, Point Loma, and it's a 6 million gallon pool. So it's a huge pool.
Wow. Are there other competitions that have more high schoolers?
As far as underwater competitions go, the MATE competition would be the one that focuses more on high schools.
Okay.
So now, part of this, the IMAX documentary seeks to engage students in STEM areas, or STEAM, if you may, maybe STREAM if you're into that. But science, technology, engineering, math, particularly. And we hear about that a lot. We hear maker spaces too. But you're actually doing that. And what can you speak about what students get from that?
Well, I think when you get a group of students together and you're confronted with, I guess you'd call it the design problem, it's coming up with the solution to have a robot do whatever you need it to do in the competition, you get all these ideas bouncing around, and you also gather people with different talents. So, like on our team, we have kids that are interested in the CAD, we have kids that are interested in the mechanical building of the stuff. Sometimes those students overlap, sometimes they don't. Then we have the electrical students and the programming students. So what's really great about, doing projects like this, and if you create a makerspace, it kind of draws people of different talents together to kind of accomplish a larger goal than what they could accomplish by themselves.
What have you learned through these years?
That human beings are natural learners, and that the public school system has a lot to learn from things like FIRST Robotics and all these different competitions that we do. And that when standardized testing becomes the point of education, then education's lost its point.
Sure.
Yeah, sure. Yeah.
Now we see teachers who are starting to, more and more schools are trying to kind of maybe see how a makerspace or something like this fits in there. There are times it can be kind of intimidating. It doesn't fit into the standard school model. You kind of having more experience here, what advice do you have to one of our listeners who might be a teacher and says, I just don't know where to start. How do I go?
Well, I'd love to say that you could take whatever we're doing and throw it into a classroom situation between 8 and 3 in a school day. Yeah. While that's possible, I haven't mastered that. Where I've spent all my time and energy and focus as far as the robotics goes has been extracurricular. So we basically, after 3 o'clock, the students and we can do whatever we want. And there is a documentary that I hate to reference another documentary when we're talking about dream big, but
documentary inception here. It's a documentary within a documentary.
There's a documentary called Most Likely to Succeed, which follows one of the schools, High Tech High. It was Bill Gates.
Sure.
And they basically talk about this same premise where the kids have to get together. They're doing it during the curriculum, and a lot of the project itself overlaps the different curriculums like English, history, some engineering, and woodworking and that kind of stuff. So the project they're working on kind of grabs all those things. The reason why that's successful and the reason why what we're doing is successful is because we're incorporating, and I think it's Professor Woody Flowers who came up with this term. If not, he's used it. I've heard it. And it's called three-dimensional learning. And so the three-dimensional learning incorporates the content, which is obvious. Mm-hmm. Then you have the social relevance, like why is this important to you? How can you use it in your life? And then there's the physical activity, getting up, not just sitting constantly and just absorbing information, but actually doing something with the information and experiencing the pitfalls of it or the failures of it, and then how the nuances make a difference whether or not something succeeds when you're trying to build something. So when you have that level of in-depth learning, you can't cover as much material, but what you learned is there forever. Because that was one of the findings in that documentary, was that compared to a traditional high school, they did not outscore them in a standardized test. Mm-hmm. However, 6 months later, when they gave that same standardized test, the high students got the same score. The traditional high school got lower scores. Yeah. So there's this, I guess, new approach that in-depth learning is more substantial than trying to just cover all the material because the state standards tell you have to. Mm-hmm. And I think education's kind of in a revolution because they're kind of torn between the two. They understand what good education is, but there's a lot of legislation and politics in the way, because the way they measure success, they want a checkbox, and real learning doesn't fit in a checkbox. Real learning is, what can you produce? How do you demonstrate that you can solve problems?
I feel like, it bothers me because those skills we know are very employable. And it seems like when students are being, in an interview process, then it's being measured. Like, then it's being accounted for. They're looking for it. Maybe I'm naive in thinking that, every company has it figured out. But we certainly are looking for those skills that are being developed later down the road to find a career or something like that. And they've been able to appreciate it. I mean, you don't go to a lot of job interviews with a standardized test as your first step.
Exactly.
And that's what I can't marry those two ideas.
Sometimes you do, but usually those are, it's more routine jobs sometimes, and there's a big difference there. And we might call them 21st century skills, but for lack of a better term, but they're not assessed readily in our schools right now. And they are probably relegated more to after-school programs like you're talking about as well. Do you have any advice for us to branch into the schools that way?
I would say just keep trying to, present your ideas every opportunity you get. I mean, this podcast may be one example of people it might reach. It might reach some administrators and school board members. I, right now, have been, the last 2 years, been doing public speaking where one of the things I'm asked is, if you're not so standardized tests, then, how do you assess whether the kids are going to be successful or not? And I don't know if I have the answer, but I have an answer. Mm-hmm. So my answer would be, you take 4 or 5 kids, you put them in a room with a box, and you tell them, you guys have 1 hour to identify what the problem is. and you need to come up with 2 or 3 possible solutions on how you might solve that problem. Whether it's actually solving it or not is irrelevant, but we need to see your thought process. So if I come back in an hour and they can identify what the problem is, that's half the battle right there. The second half would be, did they come up with some systematic way for testing a possible solution, even if it's not correct? Because when in real life do you ever get anything right the first time?
Exactly.
But on a standardized test, you have to get it right the first time. So the standardized tests don't reflect reality. It should be a small measure, much smaller than what it is right now. In order to graduate high school, you need to be able to, if you want to survive in this 21st century, you need to show that you know how to learn what the problem is and try to find solutions for that. If you can do that, I don't care what subject you're in, you'll be successful. Because one of the things I tell the kids too is, and you hear this all the time, the kids that are graduating now, they're not going to have the same job the rest of their life. So learning the content is not the main thing. That's the side effect of what happens when you learn how to solve problems. They need to learn the scientific process, or they need to learn the method of learning. How do you identify what the problem is? Those are the kind of things, the skills that need to be given. And then with the use of Google, because that's where the content is, how do you ask the right question? And how do you know, because this is relevant today too, whether the news or information you're looking at is real news or fake news? Yeah. You got to be able to tell the difference. So it's creating people that can think and analyze and solve. That's what the focus of education should be. Content should be second.
Well, just the first step of knowing to ask the question.
Exactly. And many kids, you put them in that situation and they look like a deer in the headlights.
I have so many things spinning in my mind. One of the things that I'm thinking about right now, and Dale and I work with teachers in integrating technology in their curriculum, and I've been noticing lately that, and maybe it's just anecdotal observations, but I feel like students are afraid to click more than they ever were. And I, basically kind of explore on your own, and it's almost like no, I don't want to get it wrong kind of a sense.
Yeah.
And train them that.
Yeah, that's what public school has done. We've been programmed that if you don't mark the right answer, you're going to be penalized when there's no reward for failing. And, so an example, in my classroom, if a kid takes a test, I let them take the test as many times as they want. And people will say, well, then eventually they're going to get the right answer. I go, but think about that. They're going to take the test 5 or 6 times before they get the grade they want. They're going to see the information 5 or 6 more times than it would if I just let them take it once and say, oops, sorry, that's your grade. So I don't like, to create, and studies also show that people don't learn when they're under stress. So if you take the stress out of it by saying, you know what, here's a test. If you don't do well, you can take it again. You can take it as many times you want until you're satisfied. What is wrong with that model? Why is that so seen as such a negative thing in education?
Because it used to be a gauntlet. We used to have the luxury of saying we'll bring some kids through, and the rest will have, a job somewhere else.
And so that's why the kids are suffering.
I'm also thinking about rubrics too, and we see projects that are assigned, and you can be creative as long as you fit within these very strict parameters. And again, I wonder if the students are being too limited in what they can do. Again, it's going through my head. Are you familiar with the next generation science standards?
I hate to say I'm not, strictly familiar with it. I probably know what some of them are, but no, I don't. I can't say I can quote them.
Well, I'm hoping, of course, that some of the engineering practices that are built into science will change some of that, and allow students to do some of that discovery and failure as well, and maybe hopefully in a way that is assessed properly too.
I think those standards speak to what we're talking about. Whether or not every school, every district, the states will be able to meet those goals, that'll be a challenge.
Well, I think a lot of it comes down to the politics of it. How are schools going to be measured? If they're going to be measured using a standardized test, then no matter what other thing you introduce, the thing that the administrators, the school board, everyone's going to be obsessed with is who has the best test scores. So just as a case in point, when we went to that competition in 2004, we were competing against people from MIT who by far outscored our students on standardized tests. And if it was a fluke, it might have just happened once. Well, we went back to the competition 2 more times. We got third place the second year in the college category and second place the third year, but all 3 years we beat MIT. So the standardized test has a place, but the problem is education has taken it, and with the help of politics and people that want to use schools for their advantage one way or another, have made it the focus, and that's what I think has damaged education. That's why kids are afraid to ask questions. That's why kids are afraid to take a chance, because they realize, well, I can't do anything unless I know for sure because I might get it wrong. Well, that's what we taught kids, that you cannot be wrong. And that's, that never happens. And everything we do in robotics, half the time something's wrong. And we have to look at why did something fail? What can we do to improve it to make it not fail? Or maybe that idea isn't worth doing. We should come up with another idea. When is that ever used in education?
Yeah. Well, we do it a lot with in leadership and teachers, but we don't have the kids go through that process as much. I want to know, Fredi, you've obviously gone through this competition, and you've gone through it many years, and that was over a decade ago. Where are these students now?
You're talking about those original 4 students, or all the students
in general? Yeah. What are they doing now? Has it helped them?
Yes, the majority of our students go on to a 4-year institution or into the military. And I would hate to be quoting a number, but it's in the 90-something, 95, 96, 97%. Now, you could say, that's because of what we're doing, but I can look at it the other way, because I also learned statistics can be looked at from both sides. Anyone who's willing to stick with us all year long, during the school year, from 3 to 6, is not going to be the kind of kid that's not going to be successful.
Sure.
So they've sort of weeded themselves out. So it's kind of ridiculous for us to say, well, we take credit because it's what we're doing. The only thing we can take credit for is that we created this scenario where those kids could thrive. That I can say.
You give them opportunity.
It's not necessarily the content. It's more the fact that they're spending 3 hours a day, every day, after school, solving STEM problems with either adults or experts in the field or whatever. And so they're learning those skills so that when they go to college, they get a bad grade on a D or an F or a D. They go, okay, what do I need to do to fix this? Let me look at what I did wrong. They know how to solve problems because that's how they've been trained in our program. So majority of them have gone on to college, a lot of them on scholarships. And with the political climate, some are undocumented, some are documented, so that part of it doesn't make a difference, because the thing we really point out, because this is what really happened after 2004, that it became impossible for any student to come in our program and say they can't do it because they're Latino, or they can't do it because their parents didn't go to college, or they can't do it because they didn't have any money, or they can't do it because of their documentation status or whatever. All those things were blown out of the water. Here's the only thing that determines whether or not you're going to be successful. Do you want to be successful? That's it. If you're the only one that can decide whether or not you're going to be successful. And, of course, you always get the smart kid that'll say, well, we have more things against us. They say, well, that's true. But it's still your choice to take on those things or let those things dictate what's going to happen to you for the rest of your life. That's your choice. If you control your destiny. You're the one that decides this. Once you realize that it's not society, it's not the stereotypes, it's not your demographics, it's your willpower, then you can find a way to get through.
Oh my gosh, I'm excited now already. I feel like I should...
I stood up in the middle. I'm holding my mic in hand. I'm excited. It's a pleasure to talk to you, Fredi, and it's really uplifting to hear this sometimes. We hear sometimes teachers getting beat down about what they can't do, and you're an example of what you are doing, and I think it's very inspiring for all of us. Well,
thank you, but I'd also like to say that I can't do any of this alone. I have a lot of people that I kind of recruit or wrangle into helping me, because one of the things you learn as a young teacher is you can end up biting off more than you can chew, and you need to have other people to help share the work. It's a team effort. The same thing you're trying to teach the kids, it's the same thing for the teachers involved in the program. I just happen to be the face that gets the attention, but there's a lot of people in the background, and I'm sure this is true with anyone who's successful. There's always people in the background that help you be the one that's out in front. So I'd be remiss to not give them credit. So I'm making sure, in case they hear the podcast.
Well, thank you so much for your time.
Yes, if listeners want to see more of your story, it is in the new IMAX film, Dream Big, Engineering Our World. You can see Stinky the robot. And a lot of other great stories, human stories. It's really uplifting. Fredi, thanks so much for talking to us today.
All righty. You mind if I throw in one more thing?
Oh, for sure.
Absolutely.
Go for it.
So I don't know if you guys are aware, but there is the Hollywood movie too, and that movie's called Spare Parts, and it stars George Lopez as a combination of Ian Cameron. Oh. And the robots made for that movie are the robots that starred in Dream Big, because we happen to have be called the movie Stinky around.
Okay.
Stinky is no longer operational because it's kind of outdated and kind of cracked, and it did have a leak, and the tampons are still inside. But there's also the documentary Underwater Dreams, which was made at the same time that the movie Spare Parts was made, and that was made by Mary Mazzio at 50 Eggs, which is a phenomenal documentary, and it was shown at the White House during Robotics Week, and President Obama recorded the intro for it.
Oh, excellent. Well, we can get links to both of these in our all of these in our show notes, and direct more people to different ways they can see these things.
And ridiculous as it sounds, there's even a book. The book is also called Spare Parts, and it basically goes into the lives of the kids when they were young and what the teachers were like when they were young. And that was written by Josh Davis, who wrote the original article in Wired magazine that broke open the story.
Excellent. You've provided a variety of ways to access the story. That's awesome.
Well, thank you.
Thank you very much.
Thank you.
For links and other information related to this episode, visit laboutloud.com. You can send us your questions and comments at laboutloud.com/contact.
If you enjoyed the show, make sure you've subscribed on iTunes, Google Play Music, Stitcher, or your favorite podcasting platform. And if you really enjoyed it, consider leaving us a rating or a review. Your feedback helps others find our show.
Until next time, I'm Dale Basler.
And I'm Brian Bartell.